Okay, so we're going to do this in a console app, and then we're going to define timer, timeout, X, stop is false. Okay, so this is going to be our control of when the system shuts down, when it all stops. So we're going to start off timer with reading the value of elapsed milliseconds. I don't care what the number is, and so we'll never really print the timer. We're going to start a variable and set him to negative of type integer, and we're going to set him to be -1. All right, so repeat. This repeats until stop is true. So if elapsed milliseconds, so we're looking at the current value of elapsed milliseconds, is greater than our timer, well, our timer is frozen before we got to the repeat, so that's when it just started, plus our timeout. Okay, we set our timeout to be 300. Yeah, 300 is actually a pretty good gap. Okay, so that's almost a half a second. It's 1/3 of a second, roughly. So what I'm going to do is say, okay, we've hit 300 milliseconds. I'm going to increment X, and then I'm going to print to the screen, hey, X is now, here's the milliseconds. Okay, X is now, all right, let's make it fancier. So we can come in here and do this. All right, now we're going to print the value of X, and then we're going to print a parent, and then character 9, if we come back up here, character 9 is a tab key. So then we're going to press the tab, and then we're going to say milliseconds equal to string of the milliseconds, and then we're going to hit a carriage return. All right? And then we're going to come down here and say, is X greater than 9? Oh. So if it is, we're going to stop. So we're only going to do this 10 times because we're going to start at 0. Okay, he starts at -1. X is now 0. And then we go greater than 9. So actually, I guess that's 11, isn't it? Okay, and then we're going to stop. All right, so let's run this and see what happens. So what has happened? I wish there was a way to pause that. There probably is. There we go. So you can see it printing every 300 milliseconds. Now, I want to show you if we kicked it back to 100 milliseconds. Watch closely. Boom. We can kick it to 800 milliseconds. That's going to be real slow. Okay. That's almost a second each. All right. Now, this is an important thing. I want you to think forward in time. When we get to graphics, this is how you cause animation. Each time that we're getting to that 300 milliseconds, we're going to display a different position of our character. And he's going to be moving his feet. He's going to be moving his arms. He might be shooting a pistol, bullets flying across the screen. Each of those will have their own speed. And all we're going to do is clear the screen and then print right on top of where we are. So that's how animation is created in programs, is through this concept of elapsing counting elapsed milliseconds. Everything has a different speed. Okay? And in between that counting, you're going to display a bunch of stuff. Okay, so let's move to the book example 2. And he's doing basically the same thing I did. He's just doing a single pass. Here, we'll just go ahead and run. Oh, crap, I pushed a key. Okay, so he loaded 2 definitions of ships, and then he loaded his structure with various values coming off down here at the bottom of the data section. All right, now his second example is going to get a lot more cool. Here's the beginnings of animation for us. All right, now our bullets are going to go from the top of the screen to the bottom of the screen, and it's going to be text, okay? But that's, text versus images is all the same thing to the computer. It doesn't care. So we'll eventually get to putting images in there, but we haven't done images yet. So what we're doing, this is going to be our window looping here coming up. So we define a missile. Okay, a missile has a speed. Oh, God, I hate that he uses this. Drives me crazy. I know it's using less data, but I'm sorry, I don't like these things. All right, now if I change those, the program's going to get all bent out of shape, right? Maybe not. Oh, good, you're not loading them from data. Okay, so let's see. Let's just continue down. If I have a bug, I'll fix it. Okay, so we define a list. Now, I haven't introduced lists yet. Lists are very similar to arrays. So for the moment, just with this, it may as well have been an array. One of the main differences, you can't delete records from arrays. You define an array with 10 elements. There will always be 10 elements. I can't go in and delete element 4. It doesn't work that way, because 4 has to be there because 5 has to be 5. Okay, and those don't change. In a list, I can delete any record I want, and all the records just move up automatically, just keep moving up in the list. The penalty is, if you're referencing that you're playing with list element 3 and somebody deletes 2, record 2, well, your list record 3 just became 2. Okay? But you can delete, you can add on the fly. It can be, you may have one item, you may have a million items in missiles. All right, but we're going to do lists, but you got to understand that for this code to work. So here's our, let's see, this is doing the exit condition, pressing a key in our missile text. Okay. So we have our current time timer, and then we have, oh God, I didn't go into this. Okay, fire delay. Believe it or not, the looping here runs so fast that if you hit a key, you will normally fire anywhere from 3 to 5 things with that hit key. You can't go fast enough to push a key down and let it go in one loop of the program. So the program's looping, and he may loop 3 times or 5 times, and all those times he's saying, hey, you pushed the key, hey, you pushed the key, hey, you pushed the key, and he's going to keep firing. Okay? So there's a trick to saying, I hit the key, and I only want you to count 1 key press. Ignore the rest. Okay, so that's used with fire delay. This is our delaying. If fire delay variable is greater than 0, then each iteration of the loop, we're going to subtract 1. All right? Now, keep that in the back of your mind. Here's our timing. If current time is here, current time is looking at elapsed millisecond. So I've frozen elapsed millisecond at the beginning of this loop. Remember, milliseconds are quick. When we get to this command, guess what? Milliseconds is no longer what it was here. All right? So all of this does take time. Millisecond, just to make sure you know, is 1,000th of 1 second. They go by real quick. Okay, so we're going to do only on our timeout are we going to do something. And what is our timeout? Our timeout is set to a ½ second. All right. So we're coming down here. What are we going to do? We're going to clear the screen. We're going to start drawing. And we're going to spin through our missile list. And we're going to say, okay, missile list, you have let's come up here and look at our structure. A bullet goes, or a missile travels at a certain speed. that speed's going to be anywhere from 5 to 20 pixels. We haven't gone into pixels, but let's just say you may have 100 pixels per an inch. All right, so 5 is barely moving. You can get through 1/5 of an inch at 20, right? All right, so then max distance. How far can our missile travel before it's dead? Okay, that may be 200 pixels. It may be 800 pixels, okay? And I don't let it go this far. This is I think I changed this to be 50 to 500, okay? Because our screen is only, what is our screen height? He has this going vertical. Let's see, our screen is only 480 tall. So, I mean, why would I go 5,000? That's way down below us. All right, so anyhow, that made no sense to me. And then, where is our current distance? So that would be tantamount to saying, where's our missile? If we're tracking it vertically, that's the Y element. We're tracking this vertically. So he's going to start at 50 on our screen, and then every time he moves each one of these will move at a different speed, and they will only go so far as to the type missile, and then they'll vanish, and then we're tracking current distance. All right, now let's come down here to our code. So we're going to increment current distance to be missile current distance plus missile speed. So we're going to travel at whatever our speed is. So we're going to then say missile text is missile speed, and we print the various fields. So we have max distance, current distance, and that stuff. Okay, then we're going to draw the text to the screen, and then we're going to say, okay, if the distance is greater than our max distance, so, or if the distance, the bullet has left the visible screen, really, delete missile. So now we're going to delete records in our list. All right, now another important thing. Yep, and I did this. Oh, I did do this right. Good. So when you delete records, you cannot go, remember, we're iterating through our lists. Think in terms of this. So we're on record. This is going to get real mad at me. We do record 0. I do record 1. And maybe we have 2 and, and 3, right? So if record 1 has gone as far as he can go, and I delete record 1 in a list, 2 becomes 1, 3 becomes 2. When I iterate the list, I was on 0 and 1. I deleted 1. Now I'm going to go to 2, which was 3, correct? So I've skipped what was 2. This is a horrendous issue. So now what we're doing is we start from the bottom and we go to the top. So we have 0, 1, 2, and 3. And we're going to start with record 3. We're going to put him on the screen. If he gets deleted, cool. We delete him. Our next record is record 2. He doesn't get deleted. We go to this guy. We then go to this guy. And if we delete him, he then moves to 0, and he then moves to 1. But we're done with our list. And now we have 0 and 1. The next pass will start with record 1 and go to 0. So you always read from bottom up if you're changing the list. See, that's what this is doing. For X equal, instead of our normal 0 to record count, we're going to say our record count, that's what this is, list size, adjusting for record 1 being 0 minus 1 to 0 step negative 1. So he's going to start at 5 and then go to 4 and 3, 2, 1. He's going to just read the list backwards top down or bottom up. So as we delete from our list, all the referencing values change. So you always, you got to do it bottom up if you're changing the list. Okay, so let's see. So for, now this is another important thing, and I want you to play with this for a while so you can see what's going on. You're going through here, we're iterating our list. Okay, if, let's collapse some of this junk down. Okay, so if it's time to print, great, print it. We go inside the loop. If it's not time to print, remember, each loop we clear the screen. All right, so I have to print everything. All our missiles have to be printed again exactly where they were. So what we're going to do is, if it's not time to move them, all we're going to do is print them. Okay? And then down here, we're going to look to see if you've pressed a key. We're going to automatically throw our fire delay to 30, so you can't fire another one until 30 loops have passed. Now, that's about 1/4 of a second. So you can now let go of the key. If you just hold the key down, you may find yourself fire. Okay, and that's not what you're really supposed to do. So let's see. If our list of missiles is less than 20, so we have 20 total in our list, 0 to 19, then we're going to add another missile to the bottom, and we're going to give him a random speed, we're going to give him a random distance to go to, and we're going to say current distance equals 0. Now, random, we haven't touched on random. Random returns a random number between max and min. So in this case, we're going to say somewhere between 50 and 450. It's going to start off, or that's where it's maximum going to go. Then we look to see if the keyboard has been pressed. All right, let's run this and take a look, see at what we got. So we have a blank screen. I push the space bar. I push the space bar. Now, if you notice, some of those are passing the other ones because they're at a different value of speed. They're zooming past the others, and then they vanish whenever they run out of steam, run out of their max distance. Okay. So there we go. Check it out. So soon, instead of text, we're going to be putting graphics there. So it's going to be a little cool little bullet looking thing flying down the screen. Okay. All right. So that pretty much concludes this. This is probably an enormously long video. As always, I want to thank you for your time, and be sure to play with the code. Matter of fact, I really want you to retype the whole thing so you get a full understanding of how this is working. And I'm going to slow down these videos to once every other day or so, so you have time to play. That's very important that you play with the code and type the code. I can't stress that enough. That is how you learn. So as always, thanks for watching.